Here we go. All right, game on. We're taping there, Chief. Or watch your language. Huh? I'm talking about earlier. Shh. All right, you guys recognize this? This is one of your anyone? Homework. So I figured I'd go over one more, just to remind you what you did Friday, long weekend. This should be fresh in your mind. At least remember that we had these people. Who wins the piano? Wins the bid? Judy. Who wins the lamp? Kathy. Sculpture. Armoire. Kathy. So the very first thing you should do is circle or highlight. Wasn't that cool? Who won? And then that's not your job. Your job is to identify who won what. Your job then next is to start writing down stuff, which number one, or actually step two, I guess. What is the compensation fund? That's as if they did pay this money, but we're going to write this down on paper, figure it all out. Then when we get to step five, what does everyone walk away with? That's when the payments come in. So 2 people out of 3 win, a couple objects each. They will pay for it. So they put 84.35 into the compensation fund. The next one I kind of doing this morning, kind of circumvented the situation real quick. You do get you add up all of their bids individually. That's why these are 3 different numbers. And then you take 1/3 of that. That's their fair share. 1/3 because there's 3 people. 1/3 of their total, what they feel everything is worth. All right, so that's why each one is different. So I did those sums, divided by 3, and then wrote that final product down. Then step 4, you subtract those numbers from the compensation fund to figure out what's left over. Mathematically, there will be money left over. These are averages of lower bids in some cases. When you take 1/3 of that, that will be less than the 4 bids, highest bids added together. When you subtract those 1/3 of those 3 amounts there. So that number is 903 that's left over in there. Just to be aware that if you know that you did this right, there should be money left over after you subtract the 3 numbers there. Divide that by 3, and we're going to distribute that evenly. $301 is going to go to each person. So now what really happens? All right, this is going to go slow on purpose, and this should be for checking. And this is for those individuals that didn't check online when I did supply the solutions. And again, you can lead a horse to water, but you can't make them drink. All these things are out there for you to succeed. Isn't that going slow? All right, so number 1, what does Judy get? Well, she gets the piano and the sculpture, right? But she's going to pay for it. But first, she gets her $25.40. She gets the $301 that everyone gets, but then we're going to take the costs of those piano and sculpture and subtract that from her distributions. This means she owes or will pay $2,559 to get that piano and sculpture. Not bad when they are worth $5,400 in her mind. So she does walk away with a lot of value here. Kathy gets her $24.30, her 1/3 of her perceived value of things, plus the $301 left over, minus the 2 things that she bought. And what does Sharon get out of all this? Cold hard what? Cash. I wanted to say that before it came through here. But back to Kathy, she does get a negative number, but she's only paying $304 for things that she perceived to be worth $3,035. And then Sharon gets cold hard cash. And like I told the other hours, these numbers will be equal, meaning these 2 negatives equal what Sharon's going to get as cold hard cash. So basically, they give her that money. So that's their payment, and that's where it goes, and that's how it all shakes out. All right. Should not be a problem. All right, it's go time. Blah, 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 blah. Talking about our days off. Thanks for coming, by the way. Were you tardy? No? Good. I forgot to take attendance. Remind me. Okay, so now today's something different, and I liked doing it as a PowerPoint because I think this one does work. Ma'am? Ma'am? Isn't that fun? All right. So this is different. And the scenario is different. It doesn't deal with money. It's not dealing with an inheritance. It's dealing with it's dealing with it's dealing with giving things away. All right. So the example I used third hour was my three kids. I go to one of those claw machines and I win 3 stuffed animals. And I go back. What do you think the problem with that? What happens with the kids? What happens? I have 3 stuffed animals. I'm going to give them to the kids. What happens? Someone wants a certain one, and then they start fighting. So you go, okay, this is what we'll do. We'll do this little point system. All right? So 3 kids, 3 stuffed animals. Okay, that's number 1. When you do the method of points, the number of items equals the number of people involved. And it's a system where we vote. Well, it's like a little voting system where we try to give the most fair thing out there, although not everyone's going to get exactly what they want. All right. Now, the next thing I wrote up there is here's some math to know about this. If you can't see that far, it does kind of blend in as I step way back there. That says 7 exclamation point. Does anyone know what that is? This is randomly just a math thing. What is it? 7 times 6 times 5 times 4 times 3 times 2 times 1, and then you get that product. This is called 7 factorial. All right? Now, just to share this with you as a mathematical concept that you may have never seen, all it's used for is a scenario like this. Say I have 7 students and they race, a running race. Let's make it simple. There is 7 factorial different ways that race could end. For you, you could end in one of 7 positions. For you personally, you have 7 possibilities. But when we talk about how many different ways 7 people could finish, it's 7 factorial. There is 5,040 different ways that race could end. And that's where factorials come into play. And then it actually comes into play for probability kind of permutations and combinations. Anyone ever hear that word, permutations, combinations? Only a couple, this Lockport math curriculum. All right, missing a major concept there. We do a little of this next semester as well. What does it do to this? Well, let's talk about what we have to do first. Okay, so it's not hard, it's unique, it's different. Number 1, I take my 3 daughters. Okay, put a number on each stuffed animal. Your numbers have to add up to 100, and you put a higher number on the stuffed animal you like the most. So you got a unicorn, a bear, and a turtle. I don't know. So Sammy Samulus, that's what I named her, Sammy Sammy. Yeah, it's a true story. Likes the unicorn the most. So she says to herself, I'm going to put 50 points on that. Then I like the bear maybe a little bit better than the turtle. So 30 on the bear, 20 on the turtle. She puts on her piece of paper, hands it to Dad. Dad's like the secret, gets all the ballots and then does the work for this. Well, I said 50, 30, 20 because what does that add up to become? You don't have to write that down. We're going to have an example. I'm just trying to give you an idea of what happens first. Then the other 2 put different point values on depending on which one they like the most. Step 2, my job would have to take all 3 sets of votes and list all the possible arrangements with the points that they voted written down there. So, all right, this is the time to write this down. How many kids are there? 3 with 3 stuffed animals. So there's 3 times 2. There's 3 factorial. 3 times 2 times 1 arrangements. There are 6 possible ways that the stuffed animals can be given out. Let's talk about the first one, Sammy getting what she wanted. Sammy could get the unicorn. Sorry, I had to think of that. Sammy could get the unicorn. Then Brianna could get the bear. And Lexi can get the turtle. Or Sammy could still get the unicorn. Brianna could get the turtle. And Lexi could get the bear. That's a different scenario, right? So even though Sammy still gets a unicorn, there's 2 different ways Sammy could get the unicorn. This is what we're talking about, the possible arrangements. We have to write out What are all the scenarios in this? Here's where this can get real bad, where I can be real mean, and I think the notes 2 years ago did have this. What if I had 4 people with 4 things given out? That's 4 times 3 times 2 times 1, just change the dots instead of x's. That's 24 different scenarios of how 4 stuffed animals can be given to 4 kids. And you'd have to write those out, and it'd be a lot. 5 factorial. What's 5 times 24? Isn't that 120? There'd be 120 different possibilities. We're not going to make you do that. We're only going to stick with 3. Okay, is everyone okay? All right, next thing. Remember what I say about these notes. When we put them in words, sometimes they're hard to follow with what happens here. But understand the objective. We are trying to make everybody happy, which is impossible. But we're trying to at least make it a reasonable situation where somebody at least gets their second best choice and not get the worst one. So this is why we go to step 3. For each arrangement, identify the smallest value in voting. All right, so what we have to do is write out all 6 possibilities. 2 of them I already told you. Sammy Unicorn, Brianna Bear, Lexi Turtle, or Sammy Unicorn, Brianna Turtle, Lexi Bear. That's just 2 of them. Then what about the scenario where Sammy doesn't, or whoever I said, Sammy doesn't get the unicorn? We have 2 more and 2 more, 6 total. You got to write them all out and put all their vote totals next to each scenario. Now, what you're going to do is identify the smallest value. Forgot that doesn't work that way. And hope that the first star happens. When you circle all the smallest numbers in each scenario, remember, what if someone hates the turtle and they put a 10 there? I don't want that to happen to that kid. So when I look at all the smallest numbers in each scenario, the smaller ones we're going to get rid of. We want to find the highest. This is where students, their brain blows apart here. You want to find the highest small number in any of the scenarios. Because what you're saying is then that might be somebody's second choice. And again, it's probably not going to make a lot of sense until you actually see it. I'm really going to hammer this point down. So of all the small values in each arrangement, you want to identify the highest one. And if there's only one, you're done. That's how they get the stuffed animals. If there's a tie, that's the bad part, but it really isn't that bad. If there's a tie, then you keep those 2 tied values, that whole 2 scenarios, and get rid of the rest and move on to step 4. Okay, so I know this is weird. You're probably saying this is stupid. Just stick with me. It really isn't that bad. So step 4 only occurs if the second star in step 3 occurred. If there's a tie for the, I'm going to say it one more time, highest low value. What? You'll see. If there's a tie for the highest low value, then you go to the middle value in the saved scenarios. Not the highest, the second one. And see if there's a highest middle value. And if there is, that scenario wins. Sadly, if there is a tie again, then you proceed on to step 5, analyzing the last number. And I do have that step on the next slide. So if you wanted to say ditto here, because it's the same as what happens in step 3, just bumping along to the next number. I know it's a little weird. It should be a little confusing. It should be a little cloudy at this point. I cannot overemphasize, though, if you get and know how to do step 2, it really isn't bad. That's what I found. People weren't able to do step 2. They didn't know what I was talking about. They don't get my thing with the kids, where I got to list all the possible ways my 3 kids could get the stuffed animals. There's 6 different ways. And then I have to look at their votes and put the number that they put on each case. And then I proceed on to step 3. I'll pause for a second as people are writing. No. Now we're back on? All right. And then step 5 is, and again, I know how this is probably going right now. Maybe a quarter of you are kind of understanding. But remember, there was a tie for the middle number. That's the only reason we had to go to step 5. So then you identify the max point value, see which one is the highest, and then that's what the arrangement will be. So now here's the question. Boom. I didn't do the daughters with the stuffed animals. I should have. That would have been fun. But I made a boring log port. Just added a new wing. Hey, we are adding a new wing down there. And 3 teachers are going to be assigned 3 rooms, but they get a vote about it. Use the method of points to assign the rooms. Like I said all day long, we actually had a new wing put about 5, 6, 7 years ago. This is newer, that wing over there on the other side of my room. Hey, there's one room that's by the doors that you can get out of here as quickly as possible. That's the one I want. So I'm part of this. Samuelis, Truesdale, and McGrath. Anyone have McGrath, by the way? Anyone? Nice. She used to teach this class. That's why we give her props. Her name's in this as well. She moved on to North Carolina. Great teacher. So I like the room that's by the door so I can get out to my car and get my kids at home. So I'm going to put 50 points on that. 50. Then there's another room that's by the math office where I might engage in a conversation with some math teachers. I'm going to put a 20 on that, all right, because I don't like that. I see enough of them in the morning with my forced morning meetings against my will. This is all taped, by the way. Don't fall asleep. What are you doing? Oh, man. And then there's another room in between that's I put a 30 on because that one I don't mind so much. All right, so that's what you do. You do a vote system to yourself. Oh, hit the wrong thing. And here it is. And there's those things that I just said. There's Samuelis. Room 3 is by the door, so he can get to his car and beat the traffic out of Farrell so he can pick up his kids off the bus. So he put a 50 on that one, room 3. And then he put a 20 on the room that's by the math office, and a 30 on room 2. Those add up to what? What do those add up to become? 100, so that we have some equality in points, so we have a comparison. Truesdale likes room 1 and room 3 equally. Says mine being by the math office, the copier's close, does like being by the door, close to her car, and really doesn't like room 2 for some reason, so she only puts 20 on that. Then McGrath really likes room 1, copier's close, does like engaging in conversations with others, not antisocial like Mr. S. And then 30 and 10 really doesn't like room 3. Okay, so those all add up to 100 as well for McGrath. Not your job. This is given. Your job is to write out all the scenarios. So what are all the scenarios? Verbalize it first. All the scenarios, no matter what the votes are. Fumble. What could have happened was Samuelis gets room 1, Truesdale gets room 2, McGrath gets room 3, right? Or Samuelis does get room 1, but McGrath gets room 2, and then Truesdale gets room 3. That's different, isn't it? Right? Different scenario. Even though I get room 1 in both those scenarios, the second part is different. Or do I get room 1? It could be that what? Who gets room 1? Truesdale, then Samuelis, then McGrath, room 1, 2, and 3. Or Truesdale, McGrath, Samuelis. What I'm telling you to do, this is how you separate and do all the possibilities. Or McGrath could get room 1, then Samuelis, room 2, and Truesdale. Or McGrath, Truesdale, Samuelis, 1, 2, 3. So the first thing you should do is, and I'm thinking of redoing these notes for next year, is list all the possibilities, but don't think of the numbers yet. So just like I said, room 1, room 2, room 3, this is what could happen. It could be Samuelis, Truesdale, McGrath, or Samuelis, McGrath, Truesdale. Truesdale, Samuelis, McGrath, or Truesdale, McGrath, Samuelis. Or McGrath, Truesdale, Samuelis, or McGrath, Samuelis, Truesdale. These are every single possibility, and you don't necessarily have to write out the whole word, right? Couldn't you just do STM, right? Yes, Mr. Samuelis. And then after you write out all the possibilities, you write their vote number that they put. So here's where I'm going to grab the highlighter, and I'm only going to do this a couple times because this should make sense. Okay, the highlighter. So here's Samuelis in room 1. What's Samuelis' room 1 number? Here's Samuelis. Here's room 1. He put a 20 on room 1. So both of those get a 20, right? Right, Mr. Samuelis. All right, let's just snag Truesdale here in room 2. Here's Truesdale's room 2. Truesdale, room 2. Truesdale, where's that at? She put a 20 on room 2. So wherever I see Truesdale in this list, I'm going to put a 20 and a 20. See that? I'll take that lack of a response as a yes. So what you do after this is put all the voting numbers, what they put on each room. Truesdale put a 40 on room 1. Here's room 1. Truesdale put a 40. There's that 40 kind of highlighted, even though I got a bunch of stuff in the way. Did it highlight? What happened? All right. Now this is going to go to the next slide. Now step 3 will make sense. Please don't screw this up. Very simple. And again, the whole idea of this, to identify the lowest numbers in each scenario, is to not stick somebody with their lowest number. I don't want to give someone their last choice. I want to try to maximize this so almost everybody is happy. So step 3, reword it a little bit. For each arrangement, for each possible way we could assign the rooms, ID the smallest point value in each individual scenario. Pick the highest small values, and then discard the rest of the arrangements. I don't know if anyone caught that. I made a little mistake on the... Okay, so what's the smallest number in this first arrangement where Samuelis, Truesdale, McGrath, 1, 2, and 3? What's the smallest number? It's 10. You missed that. All right, next one. 20, 30, 40. Which one's the smallest? 20. 40, 30, 10? 10. See, I don't want to give this arrangement because McGrath does not like room 3. It's like one of her worst choices. Okay, but don't worry about that. I'm just trying to get you 30 is the smallest number. And then 20, and then 30. Pick the highest small values. Discard the rest of the arrangements. So this is gone. This is not how they're going to be assigned. And look at that. That was terrible anyway, everyone would be unhappy. I think that was their lowest votes in that order, right? So everyone would be ticked off anyhow. And then 20 is smaller than 30, so this is out. 10 again, out, and this is out. Now, the worst thing happened to you. There was a tie, so we must go to the next step. And you don't have to keep rewriting the chart. You can do all this figuring into it. Those are done. Cross them off with happiness. Those are not the way the rooms are going to be assigned to the individuals. We are not going to give somebody their very low vote total. So when doing this, I hope you understand the worst case scenario is McGrath or Samuelis is going to end up what they put 30 points on. By the way, what's 1/3 of 100? This could be a way of saying fair share. What's 1/3 of 100? 33.3 repeating. So at least they got something that they liked 1/3 as much as the other rooms. You know, that's kind of the idea as well. Blah, 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 blah. Okay, so now, you don't have to rewrite this down, but I just rewrote it, probably for no reason. I could have stayed right up on this one and done the next part. But those are canceled now, and the only two possibilities are Truesdale, McGrath, Samuelis, or McGrath, Samuelis, Truesdale. And these were, do I still have my pen? Yes. These circled tied values. So now what I go is to the middle value. What's the next highest value, but not the highest value in this next one? Truesdale or Samuelis? Truesdale, that's a 40. What's the next middle value here? Truesdale, 40. Unfortunately, another what? Tie. Now, I shouldn't even have to go to the next slide, but that's what step 4 said. If you see a tie with the lowest value, then you go to the middle value. If there's a tie at the middle, then you look at the last highest value and pick the highest. Which one's higher between 50 and 60, which is very simple? 60. So this means this is the arrangement. McGrath will get room 1. Samuelis will unfortunately get room 2. He got his second choice. Truesdale got one of her first choices because she equally liked one of the rooms. So McGrath does get her favorite, and Truesdale gets one of her favorites. So I didn't really need this last slide. Whoops, I didn't mean to do that, though. This is the arrangement that won. Again, in order. The 30s were a tie. They were the highest low values in each of the scenarios. These were the highest middle values that tied. This 60 beats this 50. So that's why this is the pick choice. Someone argued, well, couldn't you still do the one above that because McGrath still had a 30 and had a 50? Could have, but in sticking with the spirit of the game, it's the highest number. So McGrath does get her 60, and Samuelis, unfortunately, doesn't get what he wants. Okay, so figured like I've done before, do a quick homework assignment, but show you how a lot of these work, and they work out real nice. Especially calling them teenager A, B, and C, because writing out the scenarios is very simple. Okay, number one, teenager A. This goes, the teenagers go in columns instead of the rooms. So just read this appropriately or correctly. Teenager A says, I like room 2 the best. I'm going to put 58 points on that. Then room 1 slightly. I really want room 2. Room 1, I could take over room 3. So room 1, I'll put 22 points. Room 3, I'll put 20. These add up to what again? What do these add up to become? 100. So we have a same point value in each system. Teenager B likes room 1 a lot. Teenager C also likes room 2. All right. Naming them teenager A, B, C makes this very simple. And the way I would do it is I would put on top, well, it depends how you want to write your situation. You want to write it in rows, go ahead. I just like doing it in a column, and it's straight down. It's bigger. All right, so what are the scenarios? I'm going to write these out real quick, maybe help you out. And we'll call this room 1 here, room 2 here, room 3 here. Couldn't it just be A, B, C? 1, 2, 3. Well, what else could happen? It could be A what? Come on. CB. Room 2 goes to teenager C, and room 3 goes to B. Or does A have to get room 1? No. What could happen next? B what? And what else? BCA. And then what else? C could get room 1, and then what? CAB, and then what? CB what? A. Okay, now I got to erase all that because my new chart's really coming through. So number 1, that's what I would do. Then number 2, actually I won't erase yet because I'll show you how this chart was created then. Then what I do is I look, okay, room 1. What did A feel about room 1? A felt that room 1 was worth 22 points. I'm going to put a 22 here and a 22 here. Right? Now I'm going to make the chart look a little bit better so it'll shake out better. B likes room 1 at a clip of 52. So I got to put 52s here. C likes room 1 at 20. You could do this one way or the other. There should be no problem you getting these numbers in the right spot, though. Okay? So what we have to do is get those numbers there, but then understand these are the scenarios that are possible. And then that's what we have to check with step 3. So I'm going to get rid of that and have the chart come up. Okay, boom. And as I was trying to write out, I took my clipping that I had from the last year's notes out of a PDF. Okay, so like I said, your job is A, get the scenarios all laid out. B, cross-reference it off of the chart and get the numbers in the right spots. C, understand that these are the possible ways. Oh, I forgot my pen wasn't activated. These were the possible ways the rooms can be given out. I could give room 1 to person A, room 2 to person B, room 3 to person C. So now this is what we run through. We go to step 3 of the process and circle in green, that's what I have here, the smallest vote tally in every scenario. There you can see 22 smaller than 31 and 24. 17, 24, 20, 17, and 20. Those are all the smallest vote numbers in each scenario. And we want to pick the highest of those vote totals. This is not a tie. Don't you see 24 is the only one? Right? So this scenario is over. This is how the room is going to be, or the rooms are going to be given out. And again, the spirit of it is this. I didn't want to do this 5th one because B only put a vote of 17 on there. You're giving that person their worst votes. All right, 2 people got, I think, their first place vote, and then person or teenager C at least got their second place vote. You can't make everyone happy in this scenario, but at least it's close. 2 people got their first, 1 got their second.